let's solve some example. Let's see what we have here. Okay, so let's see. We have radical 32. Last time we talked about radical, different index. And when we don't have index here, what this means, index is 2, okay? Okay, so the first thing I will do is to write this down let me write down all the prime factors that multiply together give us 32. So we know that 8 multiplied 4 gives us 32, okay? And then if we break down 8, we will have 2 multiply 2 multiply 2. If we break down 4, we have 2 multiply 2. So overall, we have 1, 2, 3, 4, 5 of them. And then, so we can write down 2 power 4 multiply 2 power 1. Okay? Instead of 2 power 5, I wrote down 2 power 4, 2 power 1. And then we know index is 2, correct? So I can separate this to 2 power 4 with index 2 multiplies to 2 power 1 with index 2. Correct? And then here we can use this rule. X power m n is x power m divided by n. And we know if we divide 4 by 2, it can easily simplify to 2, correct? So 2 power 4 divided by 2, but we cannot touch this one. It doesn't come out of the radical. Because, so we don't want to write down 2 power 1 over 2, and it doesn't look good. So this one is the best. So 2 power 4 divided by 2 is 2 power 2, correct? And we keep the radical 2. So radical 32 is 4 radical 2. Correct? So $48. So 48 also we can divide it by 2. If we divide 48 by 2, we have 24 multiplied 2, right? And then 24 is 12 multiplied 2, correct? 12 is 6 multiplied 2. 6 is 3 multiplied 2. Right? So instead of 48, we can write down 3 multiplies to 2 power 4. Because we know we can bring out 2 power 4. And like here, 2 power 4 under radical with index 2, it came out and we have 2 power 2, which is 4, right? So let's separate this. First of all, we have 2 power 4, then we have radical 3, and instead of 2 power 4, we can write down 2. 4 divided by 2, because we know index is 2. Multiplies to radical 3, so we have 2 power 2 radical 3, which is 4 radical 3. So as you see, the simplest way is to break down this number to the prime factors. So now we have 16. This time index is 3. Means on the radical, we should have a number multiplies to itself 3 times to be able to bring it out of the radical with index 3. So what we have, we know 16 is 4 multiplied to, 4, correct? And then 4 is 2 multiplies to 2 multiplies to 2 multiplies to 2, correct? So we can write down 2 power 3 multiplies to 2. Keep the index. Index is 3. Right? So now we know index is 3. That's why I kept 3 of these powers. Because we can write down 3 divided by 3, which is 1, and bring this out, correct? Or simply cancel these two. First separate these. And then this one cancels with this one. And we can write down 2. Radical 2. Correct? Do you have questions? Okay, so now the next one will be radical negative 81 index 3. So, if you remember, we can have negative or positive numbers on the radicals with index 3, 5, 7 means odd numbers, correct? But when we have a negative number on the radical with an even number index, like 2, 4 as index, we should be careful. And later in this chapter, we will talk about imaginary number and how we can solve those kind of radicals. Okay, so now let's keep this negative, and I want to break this down. We know 81 is 9 multiply 9, right? Okay, 9 multiplies to 9. I know that 9 is 3 multiplies to 3, right? 3, 3, 3, 3. Correct? So I can write down negative 3 power 3 multiplies to 3. So if I write down negative 3 inside the parenthesis power 3, what is the answer? Negative multiply negative multiply negative is still negative. Okay. Negative 27. Okay. So it means on the radical we have negative 27 multiplied 3. Correct? Okay. Which gives us negative 81. Correct? So we can write down this inside the parenthesis. Means we had a negative 3. We multiplied that 3 times to itself. So right? Let's separate them. Negative 3 power 3 index 3 multiplies to 3 index 3. Oh, look at this. Here I forgot to put the index 3 for the second radical. If we separate them, both of them should have the same index. right? So now this one cancels with this one. Negative 3 comes out, but we cannot bring out the other 3 on the radical. Okay? Okay. Do you have any question?
So, how do you know which number goes out of the radical?
So, index is 3, correct? So we found a number multiplies to itself 3 times. So if we found a number multiplies to itself, index times we can bring it out. But can we have any number multiplies to itself three times to give us 3? No. So we cannot touch it. We cannot bring it out. Okay? Because there is not any number multiplied to itself, give us 3. That's why. Okay, so the next question says, now we have 48, index is 4. Means we should find a number multiplied to itself 4 times, okay? So 48 was, you remember how many times? 2 multiplies to 2, multiplies to 2, multiplies to 2, 3. 3 multiplied 16 is 48. So now, as you see, 2 multiplies to itself 4 times, but 3 is alone here. So separate them. Don't forget the index for this radical. Cancel these. It comes out, but 3 stays inside the radical with index 4, because we cannot have any number multiplied to itself 4 times to give us 3. Okay? Any question? Okay. The next one is 27 x power 3 y power 4. Index is 2, correct? When we don't have any index, index is 2. So 27 is 9 multiplied 3, right? Means 3 power 2 multiplied 3, correct? So let's write it down. 3 power 2 multiplies to 3. So why I am interested in power 2? Because I want to cancel this with index 2, correct? If index was 3, I was interested in power 3, correct? Multiplies 2. So now x also, let's separate them to 2 different power. One is the one I'm interested and I want to bring it out. Cancel it and bring out, right? The other one stays in the radical. And this one, let's write it down in this way this time. Y power 2 is y power 4, okay? So, I don't separate them anymore because we already saw lots of examples. So this one cancels with this one, okay? This one cancels with this one. This one also cancels with this one. Correct? What remains? 3 comes out, this one comes out. This one comes out, this one comes out. y squared comes out, but this one stays in the radical, this one stays in the radical. Okay? So 3 comes out, x comes out, y squared comes out, 3x stays inside the radical. Correct? This is the answer. X power 4, y power 3, z power 6. Okay, let's see if you can do it on your own. So we are interested in power 3 to cancel that with the index of radical, bring them out, whatever remains, whatever you cannot cancel remains inside the radical. Shall I solve it? Okay, so 16 is, tell me, 2 power 3 multiplies to 2 multiplies to x3 multiplies to x multiplies to, yes, z square power 3. Exactly. Good. So this cancels, this one, this one. These are coming out. This one also comes out. This one and this one stays inside the radical, right? Oh, look. Oh, okay. Here, I thought it was 3. Okay, here we have 3, right? And then actually, sorry. Let's bring out those 2. X, y, z power 2 radical 2x index 3. Correct? Good. Okay, so now these were all multiplication, and now we know how to simplify this. And this new topic is about addition and subtracting radicals. Okay, so what happens if you have something like this? 2 radical 5 plus 3 radical 5.
You would add 3 and 2.
Whenever, like here, radical 5 and this radical 5 are like terms, correct? Both of them have the same index, and actually on the radical is the exact same. So one way of doing this and understanding this is factoring out the radical 5. If you factor out radical 5 from the first one, just 2 remains, right? If you factor out radical 5 from the second term, 3 remains, correct? So what do you have? 5 radical 5, correct? So this was so simple. But in other cases, we have to find out the same radical in each of terms. Let's see how we can do this. So we already worked on radical 27 with index 2, radical 48 with index 2. So let's simplify these to see what we can bring out and what stays inside the radical. Okay, so I will write down 5 radical 3 minus radical 27 is radical 9 multiplied 3, right? 9 is the square root. I mean, complete the square root, correct? So 9 can comes out and become 3, right? Or let's write it down in the way I just taught you. So 3 power 2 multiplies to 3, correct? Plus 2. What was this one? 3 multiplied 2 power 4. Correct? We have 5 radical 3 minus. This one comes out. 3 radical 3 plus. This one comes out, but what comes out? 2 power 2 comes out. Correct? Am I right? So 2 multiplies 2 power 2 radical 3. So now you see the like terms. Correct? So 5 radical 3 minus 3 radical 3 plus 4 multiplied 2 is 8 radical 3. Radical 3 is a like term. 5 minus 3 minus plus 8. Right? So we factor out radical 3 and 5, negative 3. 8 remains. What we have? 10. 10 radical 3. Do you understand this? Radical x plus 4 radical 12x minus radical 75x plus 3 radical x. So let's simplify this one and this one. Let's simplify this. So this stays the same. 4 radical So what we have? 2 power 2, which is 4 multiply 3x, right? Minus. What is 75? I know we can divide that by 3.
25
Do,
times 2.
do you remember I said how you will understand, for example, you can divide 75 by 3? Do you remember what we do? Do you remember? I said add the digits. 7 and 5 is 12. Then you will say, can we divide 12 by 3? Yes, if we can, so we can divide 75 by 3. Right? Do you remember? I talked about that. I'm sure. Okay, so now you can divide 75 by 3. 25. Okay? So we write down 5 power 2, because 5 power 2 is 25, right? Multiplies to 3x plus 3 radical x. Do you have any questions so far? Six radical x plus 4 multiplies to 2, 3x minus 5 radical 3x plus 3 radical x. So this one, this one, this one, this. 6 radical x with 3 radical x is 9 radical x. Am I right? Then this is 8, right? 8 radical 3x minus 5 radical 3x. Right? 3 radical 3x. Correct? 3 radical 3x. Correct? So we cannot add these two because radical 3x is not similar to radical x, right? So we leave it like that. Radical index is 3, 81x power 3 y power 4 plus 3xy radical 3, 24y. So I'm going to simplify this, okay? So what was that? 81 is 9 multiply 9. We could write down 3 power 3 multiply 3. Am I right? X power 3, y power 3 multiplies to y. Lucky them, they are always watching TV. Really. 3xy radical 24 is 6 multiplied 4 comes to my mind. Then 6 is 3 multiplies to 2, 2 multiplies to 2, 2 power 3, 3. Right? 3 multiplies to 2 power 3. What else we have? Y. Okay, so let's bring them out. This one comes out, this one comes out, this one comes out, this one stays, this one comes out, these two stays. So 2, 3, x, y, radical 3y, plus 3, x, y, 2, radical 3y. 6x y radical 3y plus 6x y radical 3y. Six xy radical 3y plus 6xy radical 3y. How many xy radical 3y? 6xy radical 3y plus 6xy radical 3y. How many xy radical 3y remains? 12 of them, right? Or you could say, okay, there are common factors here. X, y, radical 3y. Am I right? Then, oops, everything's wrong. Okay, let's use this actually. So from the first one remains 6, from the second one also remains 6. Correct? Is that correct? So we can write down 12xy radical 3y. Do you have any question? No? Okay. So did you see I was like hesitating here? Because there's another way also. Yes.
How do you know what numbers like go down?
Go down?
Like, you know how you put those arrows and you put like.
Oh, I mean those are coming out of radical. Those are coming out of radical. The other numbers and variables stays. So okay, here I said x, y radical 3y is the same. And from the first one, 6 remains. From the second one, 6 remains. Okay? So actually, indeed, both of them are similar. If I want to factor out, let's look at this in this way. So let's bring out the common factor 6, x, y, 3y. Okay, this is the first term. This is the first term. It's not that difficult. You just should pay attention. This is the first term. If I bring out 6xy radical 3y out of this first term, what remains?
Nothing.
Because this one is multiplies to 1, right? Or let's put it here. 1 multiplies to this, right? If I bring out this one, 1 remains, correct? So 1 remains from the first one. If again, I bring out this one from the whole thing here, you should imagine a 1 here, right? So 1 comes out.
Why?
Do you understand?
Yeah, but why are you doing that?
I'm showing different way. So here I said, bring out the common factor, and then 6 plus 6 remains. Here also bring out the common factor, which is the greatest common factor here. 1 plus 1 remains, so you have 2 multiplies to 6x, y, radical 3y. 12x, y, radical 3y. So there are different way of looking at this kind of, simplification. Do you have any question? Multiplying radicals expression. Oh, we already did that. Oh, okay. This is different. If 2 radicals have the same index, you can easily multiply them and put all the multiplication under the radical. Okay, so we know here radical 2 has index 2, right? Multiplies to 5 radical 11x. 11x on the radical also, as you see, the square root and index is 2, correct? So this is the formula. It says if you have a here on the radical with the same index as b on the radical, you can keep one radical with the same index and multiply a and b. So here also, imagine this was a, this index is 2, this is b, index is 2. So we write down 3 multiplies to 5. Radical index is the same. 2 multiplies to 11x. So we have 15 radical 22x. Correct? The other question says we have 6x outside of the parenthesis, and we should multiply this to everything inside the parenthesis. So distribute this radical 6x to each term inside the parenthesis. So we have radical 6x multiply radical x plus. Again, radical 6x multiplies to 2x. Again, radical 6x multiplied to 5. Be careful, these are on the radical, okay? So let's multiply these two. On the radical, you have 6x squared. Because 6x multiply x is 6x squared. Radical 12x squared plus radical 30x. Do you have any question?
Would that be our answer?
So, no, actually. Can we continue?
Yes.
Because we can bring x squared outside of the radical, right? And we can bring, here we have 4 multiply 3. We can bring 4 outside of the radical, x outside of the radical, right? Then here also we have, what we have? 3 multiplies 2.
5 times 6.
5 times 6. We cannot bring any of them, right? Okay. So from the first one, x comes out, 6 stays inside, right? From the second one, 2 comes out, 2x actually comes out, 3 stays inside the round. Then nothing's happened here. Okay. So let's solve more like 2 parentheses. We're at 7 actually, minus 3 radical 2 multiplies to 4 minus radical 3. 4. Do you remember? So 7 multiplies to 4 minus 7 multiplies to radical negative, like radical minus 3 radical 2 multiplies to 4 minus 3 radical 2 multiplies to radical 3. Oh, this becomes positive because negative multiplies to negative is positive. Am I right? Okay. So 7 multiplied 4 is 28. 7 radical 3 doesn't change. But this one, so we have 4 multiplies to 3 multiplies to radical 2. So 4 multiplies to 3 will give us 12 radical 2. Now we can combine these two because the index are the same, right? 2 multiplied 3 under radical is 6. Let's solve this. Radical index is 2y plus radical index is 3, 4. Multiplies to 2 radical Index is 3. Another index 3. Okay. Four. Multiply them together. Yeah. Plus radical 2y multiplies to negative 3 radical 2 plus be careful, you can easily have mistake. Plus, am I right? Right. Right. Okay, multiply them to see if you can do that. Radicals are the same, index are the same. So keep 2 here and then 1 radical. We multiply 2y to 4y squared. 2 multiplies to 4 multiplies to y multiplies to y squared. Right? Plus. I kept it like this because I'm going to show you there's a possibility that, you know, we can bring them out and combine them. So the next one, okay, plus becomes negative 3, 2y multiplies to 2, index 2, plus 2 multiplies to 3, 4, 4, y squared, minus 3 radical 4 multiplies to 2. All right. Okay. Two. Radical 2 power 3. Can I write it down? Because it's 8. Correct? Y power 3 because it's 8. No, sorry, it's not 8. It's y multiplied by minus 3 radical. Let's write it down like this because we cannot do anything with that. 2 radical. Okay, this one. 4 multiply 4 is 2 multiplies to 2 multiplies to 2 multiplies to 2 multiplies to 2. means we have 2 power 3 multiplies to 2. 2 power 3 multiplies to 2. Minus 3. And look at this. This one also 2 power 3. Right? Now you know exactly what we are doing. This one cancels with this. 2 y minus 3. We cannot change this. Nothing comes out. Plus 2. Well, this one and this one. So 2 comes out. Radical 2y squared stays. And then, okay. Good. So 4y minus 3 radical 4y plus 4 radical 2y squared minus 6. Is this clear? Do you understand this? How many of you understand it? How many of you understand it? Okay, the rest. Good. Good. So you should just practice more if you have more time. You should just practice more. And I think maybe the basic is lacking if you don't understand this. If it's difficult for you, the basic. Like how we separate 2 power 4 to, for example, 2 power 3 multiplies to 2. These are basic. So you should definitely, work on this over and over to be more strong and have a required background to understand this. Okay, so we worked on multiplication, addition, and then we multiplied 2 radicals, same index, and now we want to divide radicals with the same index. So the same thing I said, for example, if you have the same index, you can multiply these 2 numbers under the same radical with the same index. The same thing happens when you have division. So you have the same radical, but divide a and b under radical. A by b under radical. So we will start with some simple numerical example. Divide 48 by 3. How you will understand that? Add the 2 digits, 4 and 8. You will get 12, right? And then you will say, yes, we can divide 12 by 3. So we can divide 48 by 3 too, right? So I can divide 48 by 3. I can put them under the same radical because the index is 2, right? And then we already know we can divide 48 by 3, correct? So it's an easier or easiest way to divide them first and then apply the radical rather than apply the radical and then divide them. And actually that works also, but let's see. 48 divided by 3 is 16 under radical index 2, which is much easier, right? And this is 4. Am I right? Or there is another way. So we already worked on radical 48 with index 2, correct? So radical 48 with index 2 is equal to what was that? 2 multiplied 4. 2 power 4 multiplies to 3, right? And then we brought out 2 power 4, so we had 2 power 2 outside, 3 inside, right? So we already know this. So what about this one? So instead of radical 48, what we can write down? 4 radical 3. Am I right? Okay, let me write it down here. Radical 48 divided by radical 3. Instead of radical 48, now we can write down 4 radical 3. Right? So now you can cancel radical 3 and radical 3. And 4 remains. So either this way or this way. Whatever is easier for you. Do you understand what I did? I just solved it with 2 different methods, 2 different ways. Okay, so what we can do. Okay, the first thing, 125 divided by 8. We cannot divide odd number by 8, correct? 125 is like difficult to divide by 8. So I cannot first divide and then apply the radical. So what I do, I separate the radical because you should remember radical 8 with index 3 is so easy. What is this? 2, correct? Because this one is 2 power 3. 3 and 3 cancels, 2 comes out, correct? Because this is 2 multiplies to 2 multiplies to 2. And then radical 125 with index 3 is also easy. 5 multiplies to 5 multiplies to 5, correct? So we have 5 divided by 2. So depends on how easy you can, divide them or apply the radical. For this example, both way worked. So I first separated the radical, first combine them and then divide them because we could easily divide 48 by 3, correct? So we didn't have any problem. And then on the other hand also, we could use another method, separately, use the radical. But here the only way is to separate the radical and apply the radical. Otherwise, we would have some number, like decimal number under radical. Do you understand that? So it would be difficult, correct? So what about this one? There is something I see here, like 28 can be divided by 7, right? 4 multiply 7, correct? So what I do, I say, okay, if I put everything under the same radical, I can at least divide these two, right? And then x power 5 also can be divided by x. Then y power 3 stays the same. So simplify that x power 5, simplify 28 and 7 to see what you get. Divided by 7 is 4. X power 5 divided by x is x power 4. Correct? Y power 3 is y power 2 multiplies to y power 1. I'm doing this because I want to bring out this y power 2. Correct? This can come out, this one can come out, this one can come out, this one stays inside the rack. Correct? 4 radical 4 with index 2 is 2. Correct? Radical x power 4 is x power 2. See, here we have 2. So x power 4 divided by 2. Or you could say x power 2 multiplies to x power 2. Right? This one cancels, this one cancels. So we have x multiplies to x, which is x power 2. So x power 2 comes out. What else? Y power 2 becomes y, and then this one stays inside the radical. Okay, so let me explain this. Rationalizing denominator. So sometimes when we have something like 3 over radical 2, we prefer to get rid of that denominator which has a radical. We can do that if we multiply the whole fraction to the same thing as the denominator. For example, if we have 3 over radical 2, I can get rid of this. How? By multiplying the whole thing by radical 2 over radical 2. Because, okay, let me multiply them. Why I do this? Because this one is a number divided by itself, right? Which is 1. We just multiplied the fraction by 1. Do you understand? So this was an imaginary kind of fraction that we multiplied the first fraction to. And this is 1. Means literally we did nothing, correct? We are just using this 1, using this radical 2 over radical 2, because we can simplify the denominator and get rid of radical in this way. So it doesn't matter, we will have a radical in numerator. The main reason is this one. We want to get rid of radical in denominator. So now if you remember, radical A multiply radical A means we have radical A power 2, which is A, because the index is 2 here. Using this, we can say, okay, radical 2 multiply radical 2 is, using this one, radical 2 multiply radical 2 is 2, correct? So in denominator, we have 2, numerator, we have 3 multiply radical 2. We call this rationalizing denominator. So we get rid of a radical in denominator by multiplying the whole fraction to a kind of imaginary fraction, which is literally equal to 1, right? Means we did nothing. Okay, so now let's say we have three over radical 12x. So I'm going to multiply the whole fraction to the same denominator, divide by itself. So here in numerator, we have 3 radical 12x. Denominator, we have radical 12x multiplies to radical 12x. So the same thing multiplied to itself. So what comes out? 12x, correct? So we have 3 radical 12x divided by 12x. So we already had radical 12 on the radical. 12 is 6 multiplies to 2, right? Means 2 multiplies to 2 multiplies to 3. 4 multiply 3, right? So we have 4 multiplies to 3x divided by 12x. So I can bring this 4 outside of the radical, because we know this is 2 multiplies to 2, correct? So 2 comes out, 3x stays inside the radical. We have 12x. Definitely you see I can cancel this one and this one. I mean, this one is 6 multiplies to 2, actually, no, 4 multiplies to 3, right? So let's see. This 3 cancels with this one. This 4 cancels with this one. 2 remains. So finally we have 3x divided by 2x. 3x is under rad. So we call this rationalizing rad. This one is good actually. Let me talk about this and it will be the last one. So I multiplied radical a to itself and I could bring out a, right? Because the index was 2, we multiplied that to itself 2 times. So let's say index is 3. You can guess how many times I should multiply it to itself. 3 times, right? So I will have radical index 3 power 3, which comes out a itself. So here we had index 2, that's why we multiply to itself 2 times to get 8. Here index is 3. If we multiply a radical to itself 3 times, we get 8. Correct? So now I'm using this. So I will keep this here as an example. You can compare what we are doing. So now we have radical 2 divided by 3x squared okay. So here the index was 2, right? So I have 2 of them, so I can cancel the radicals, bring out 12x, right? So one more time I multiply to this one, I bring out the 12x. Here, I said we should have 3 of them, right? So if I multiply this 2 more times, do you see that? So what happens here? I have 1, 2, 3 of them. So what comes out? 3x squared comes out, correct? So on the denominator, I have 3x squared and the numerator we have all of them. Index are all the same, right? So I can put everything under one whole radical. So I have 2 multiplies to 3 multiplies, 3 multiplies, x squared multiplies to x squared. We want to simplify now, correct? So on the radical with index 3, if I have x power 3 multiplies to x, I can bring this out, correct? The rest stays inside the radical. So x comes out, 2 multiplies to 9 multiplies to x stays inside the radical. So I have x radical 18x divided by 3x squared. X radical. So I can cancel this one of this x with this one, right? So books solve this in different ways, but I recognize this way multiplying 2 more times would be much easier to understand rather than figuring out some numbers. Do you have any questions? Okay, so next time I will probably solve one more example from this section, and then we can start section 5, radical equation. Okay, if you don't have any question, we'll see you on Wednesday.